All right, in this video we're going to look at lessons 10.4 to 10.7 quiz to see how you did or see which ones that you struggled with. So make sure you pay attention to this. So let's start with this first one. Again, the order that my quiz is going to be in will be in a different order than yours. Once it loads up here we go. So my first one says find the weighted average of the random variable x. So to find the weighted average, all we're going to do is we're going to take each x value and multiply it times its probability. So I'm going to take 2 times 0.14 plus 3 times 0.37 and so on. So I'm going to go ahead and just multiply all those together. And when you do that, you get 3.79 as your answer. Now I just want to make sure you understand something here. This is a weighted average. It's not just averaging the values for x. We don't just take 2 plus 3 plus 4 plus 6 plus 8, add those all together and divide by 5. No, so it's a weighted average. In this case, the weight is the probabilities. And if you were to add up all the probabilities, that would add up to be one whole value, which makes sense because it should. It should add up to be 100%, or in this case, as a decimal, that'd be 1. So there's nothing to divide by, because if you divide by 1, it stays the same. So again, you just take each x times its weight. In this case, the weight is the probability. When you add those all together, like I said, you get 3.79. All right, so this one, suppose there's a 38% chance of snow on any given day in January. Assume that snow on one day is independent of snow on another. Find the probability of snow. Find the probability it snows exactly 15 of the 31 days in January. Round your answer to nearest percent without a decimal. Okay, so we can look at this as a binomial probability because either it's going to snow or it's not. Okay, remember if there's two outcomes, then it's a binomial probability because bi means 2. And so there's a 38% chance of snow. So the probability of a success would be 0.38. The probability of a failure in this case is a probability of it not snowing would be 62% or 0.62. So that's going to be our values for P and Q. We want to find the probability it snows exactly 15 of the 31 days. So it'd be 31, choose 15. And again, our probability of a success is that it snows. And we're going to have 15 days where it snows. And the probability of a failure would be 62%. And if there's 15 days where it's going to snow, at exactly 15 days, that means that there's going to be 16 days where it's not going to snow. And you can do this all in your calculator, all in one step. And when you do that on your calculator, we get 0.07. And then it just keeps going on, 1272755. Let's just say I just went here, 0.071. It says to write our answer to the nearest percent without a decimal. So when I change that to a percent, it'd be 7.1%, but without a decimal, it'd just be 7%. So that would be our answer here. Okay, number 3. In a binomial experiment, suppose that the probability P of success is 0.4. If the number remains constant, but you increase the probability of a success were to increase. Okay, I need to fix the wording on that. So when you guys see this, it'll be worded better. But basically, if the number of trials remain constant, but you increase the probability of success, we want to figure out what would happen to the graph. So the distribution and tallest bar would be shift more to the right, or would it shift more to the left? Cause the graph to look more flattened out, or cause the graph to become taller in the middle, or the graph would become more symmetrical. Well, what's going to happen there is it's not going to do any of these other things. It's going to shift the graph, remember, in this case, to the right, because we started at 0.4, and if we increase the probability from there, it's going to shift the graph more to the right. All right, so this one they gave us the weighted average is 4.6. And so what we're going to have to do is we're going to find the standard deviation. Remember, to find the standard deviation, the first step is to find the variance. And to find the variance, we're going to square each of our x values. So I'm going to have 2 squared and multiply that times our probability, so times 0.3. And then we would have 4 squared. We multiply that times its probability of 0.14 and so on. Now, if I were typing this out, which I'm going to in a second, if I was to type this out on my calculator, I don't want to waste my time doing the 8 squared and all these other ones because I know these are all small enough that I can square them in my head. So that's what I would do. I would just type in 2 squared, which is 4. I would times 0.32 plus 16 times 0.15 and so on. But we're gonna find out what that total is. Then after you find that total, you're going to subtract from that the mean squared. This is one of those ways that we could do this. It's my personal preference. I'd say just pick one of the ways that I showed in that lesson and stick to it. but this is the one that I prefer. All right, so then so that's going to give you the variance, and whatever your answer is, we're going to take the square root of that answer. So first, let me just plug this into my calculator. Okay, so to save you the time of having to wait for me to type it in, I pause the video, and now I have my answer is 4.12. So we're going to take the square root of 4.12, and when you do that, we get 2.0297. So I'm going to round that to 2.03 because it says to round to the nearest hundredth, so that'd be two numbers past the decimal. So 2.03 would be your answer. All right, let's look at this one. Suppose for a binomial random variable, the mean is 21 and the standard deviation is 4.1. Find the number of trials and the probability of success on each trial. Round your answers to the nearest tenth when necessary. All right, so this one, we have to do a little bit of work. We know the mean is 21. So remember, the mean is found, well, let me just write it this way. Let's start with the formulas. The mean is found by taking n times p. The standard deviation is found by taking the square root of n times p times q. So here's what we know. We know the mean is 21. So whatever n times p is, that's going to be 21. And we know the standard deviation is 4.1. So square root of n times p times q would be 21. But remember, 21 is the same as np, so I can replace np in that other equation with 21. So we would say 4.1 equals the square root of 21q. And now I would just solve this equation. So I'm going to solve this by getting rid of the square root. So I'm going to square each side. So when I square 4.1, we get 16.81. So now I have 16.81 equals 21q. So to solve for q, I'm going to divide both sides by 21. When I divide both sides by 21, I get 0.80004, or actually 0.005. So we're just going to round that to 0.8. So the probability of a success would be 0.8. Well, actually, no, I'm sorry, that's q. Q is the probability of a failure. So the probability of a success would be 0.2. So did you catch that? We found q is 0.8. Remember, p, though, is a probability of success. So p would be 0.2, because those two, we have to basically subtract that from 1. So to find out what n is, well, now we have enough information. The fact that I have that my value for p is 0.2, we have enough information then to be able to figure out what n is, because, let me scroll over here, we can put what p is in that other equation. So we'd say 21 equals n times 0.2. So if I take 21 divided by 0.2, that'll give me 105. So there's 105 items in this, or number of trials would be the value for n. So that's how you do number 5. Let's look at this one. Complete the statement to make it true. The area under the graph of a binomial probability distribution increases as the number of trials increases, decreases as the number of trials increases, or will always be 1. The area under the graph of a binomial probability distribution, even though it might look more spread out or taller in different circumstances, if you're to add the probabilities will always be 1. All right, so this one, because I have my screen a little smaller here, if I made this bigger, there we go, be able to see this better. So it says a new drug is being tested in a trial with 45 patients. The drug manufacturer claims it has a 78% success rate. Set up a formula to illustrate how you would find the probability the trial will be successful with 28 of the patients. To be clear, you're putting values in that format. Okay, so so if you're wondering what all these blanks are about, we're basically just filling in the blanks for that format. And some numbers may be used more than once, and others not at all. So, all right, so n is the number of trials. So there's going to be, or the number of, in this case, number of patients, total number of patients. So there's 45 patients. So we're going to put 45 in here for n. And out of those patients, the new drug is going to be tested, and it's going to have a 78% success rate. Okay, so 78%. So got to be careful. We're going to put the 0.78 as a probability of a success. That's our p-value. So if I subtract 78 from 1, I'd get 0.22. So that means our probability of a failure is a 22% chance. And we want to find the probability that a trial will be successful with 28 patients. So we're going to have 28 is going to be the number of patients we're going to be selecting, and it's going to be successful, or that it's going to be successful in 28 of those patients. So it's going to be probability of success is 0.78, and we want to find the probability that we have 28 successful trials with those patients. So 0.78 to the 28th power. Well, now we got to figure out what's the difference. What's 45 minus 28? Well, when you do that, we get 17. So 17 would be this last exponent here. There we go. So that's how you'd set up that problem for number 7. All right, so here it says, suppose a dart player has a 75% chance of hitting a bullseye on any toss of a single dart. We want to find, all right, it says, suppose a player throws 60 darts, find the mean number of bullseyes. So remember, to find the mean, we take just the number of trials times the probabilities of a success. And if he's going to, so the number of trials here would be that he's going to do 60 throws of the dart, and he has a 75% chance, or 0.75, of getting a bullseye each time. So we would just take 60 times 0.75, and when you do that, we get 45. So the answer there would be 45. Okay, so then it says find the standard deviation of getting a bullseye. Okay, round your answer to the nearest hundredths if necessary. So 2 numbers past the decimal. So you got to remember the first thing, or to find the standard deviation, we're going to take, let me do this in a different color actually. So we're going to take the square root of n times p times q. All right, so if I want, I can write down, let's just go ahead and do that just so that way you understand where I'm getting these numbers from. So we would have 60, and then my p would be 0.75. What I was going to do is I was just going to write down 45 for those two, which you could do if you wanted, if you understood the concept. And so then we'd have 0.25 would be a probability of a failure, that he misses and doesn't get a bullseye. So we're going to take the square root of, and if you do this all in one step, by the way, make sure you put it all in parentheses. So we'd have inside of parentheses, under the square root, 60 times 0.75 times 0.25. Or you could do it in 2 steps. Take 60 times 0.75 times 0.25 and get your answer, and take the square root of that. But either way, when we round to the nearest hundredth, so 2 numbers past the decimal, we get a standard deviation of 3.35. All right, let's look at the last question here, number 9. In a binomial experiment, suppose the probability of success is 0.4. So this is similar to that problem we saw earlier. If you were to leave the number of trials the same, but increase the probability of success, we want to see how it affect the value of the mean. Okay, so we want to see, so if we were to increase the probability of success, what impact would that have on the mean? So the choices are that the mean would not change at all, the mean would increase in value, or the mean would be half the number of trials. Now some of you guys said this one, you said it would be half the number of trials. Remember, that only happens if we leave the probability of success at 0.5, and if the increase or decrease the number of trials, then it would cut the mean in half. Okay, so so the answer here would be the mean would be increasing in value. So that's it. So hopefully you guys were able to figure out what you did wrong and where you made your mistakes or why you made your mistakes. But if you still have some questions about any of these, please don't hesitate to ask, because I'd be happy to help you and go over those in more detail.